everybody. How was last night's reception? Okay, we can try harder than that. How was last night's reception? There we go, okay. Well, welcome back. Super excited to be here for day 2. Obviously, we had lots of great announcements yesterday. We have a lot more in stock today. So as our wonderful MCs reminded us, today we're going to really focus in on the security side of the life cycle. Lots of great stuff there, but based on last night's convivial environment, I'm not sure how much we're all with the program, so I thought we'd start the day with another pop quiz, just to see how awake we all are. And so, familiar space, once again, what do we think we're dealing with here? If we guessed developers who care about security, once again, you are correct. So I think for us, as we've looked at the evolution of security, it's been interesting to see how development teams and security teams engage with each other and how that's evolved over time. I think for many organizations, the start point was what we'd maybe call reactive security, right? Developers had the freedom to build apps, push into production, and security team was really more of a monitoring function. They were sort of reacting when they saw security incidents or other things that needed to be responded to. I think this had the advantage of developer freedom and autonomy, but it had the disadvantage of security teams are playing whack-a-mole, right? You're trying to clean up issues faster than they're being created. And so over time, I think we saw a shift away from that into more of a gatekeeping model. Security said, okay, why don't we prevent the issue before we have to clean it up, which is always easier, right? Ounce of prevention, pound of cure. I think this had the downside, though, that it took away development autonomy. And now oftentimes you had to file a ticket, wait for manual reviews, and it introduced a bunch of delays into the process and took away some of that self-service experience. So in our mind, the right natural evolution of that really moves to having security integrated into the automation, right? And this way we can get the best of both worlds. We want the developer self-service, we want application teams to have the freedom and autonomy to deliver their apps, but we want security integrated into that process versus trying to bolt it on afterward or acting as a gatekeeper, right? So that's kind of how we think about security lifecycles. How do you sort of think about that natural tension that exists between these different parts of the organization? And ultimately think about how do we protect key data? How are we inspecting to make sure we don't end up with secrets in places they shouldn't be? And how do we connect apps to apps, users to apps, system to system, all of that kind of good stuff. So there's a full life cycle around it. So I want to start by talking about inspection, right? I think the kind of start point on a lot of this stuff is, do we even have a handle on what the estate looks like, right? Do we know where the problems are? Do we know where the credentials are? And I think the original problem we started and identified many, many years ago now was really this notion of secret sprawl. Credentials end up everywhere, right? They're in Git, they're in Jira, they're in Slack, they're in email, they're in pick your favorite, an Excel sheet on a network volume. And so how do you start by just even having a sense of where all these things are? You have sort of a secret scanning or inventory or discovery problem, right? So we started solving this problem with the tool we called Vault Radar, which is really focused on basically being able to connect to all the different systems that we use for human collaboration, scanning them to find all those secrets, but then continuously scanning them, because as we know, it's not a one-time thing, right? Even if I perfectly protect all my secrets, next thing that happens, my developer takes that out of Vault, files a Jira ticket, and puts it in, here's my repro step with the database credential, right? So I'm super excited to announce today that we're taking HCP Vault Radar into public beta to solve that problem. Super excited about this one. I think one of the things we've consistently seen throughout the private beta was if you think we're going to find 500 credentials, I promise we'll find 5,000, right? So, one of the things I want to talk about is some of the enhancements that have come since the private beta was announced. Starting off with the HCP Vault Radar agent. I think one of the key pieces of feedback we got was, we like Radar, we like the experience, but what if we have self-hosted systems that aren't accessible from a SaaS, right? I might have self-managed version control, or I'm running, Atlassian on-premise, and so it doesn't work if I don't have the network connectivity within my data center. So the agent lets you basically run that locally. You control it. You can put it on your private network, whether on data center or cloud, and that allows it to sort of scan all of those systems locally and only send the metadata back up to the cloud. So all of your IP stays local on your network, and you don't have to worry about creating, opening your network up to the public internet, right? The next one is really thinking about throughout the entire life cycle of how developers interact with version control. How do we prevent at every step of the way a credential ending up in the version control? So if we kind of think about that life cycle, it starts all the way on the developer's workstation before they even do the commit. So we can integrate Radar with a pre-commit hook. So before the developer is even able to do their local commit, we can do the scan and intercept it and say, no, you can't do this. There's a credential we found. As part of it, remove that before you do your local commit. Then before you do a push to, let's say GitHub, we can have a pre-receive hook that can catch it at that point in time as well. So maybe the developer's pre-commit didn't catch it. We can now catch it at pre-receive and prevent it from being accepted. Maybe it did get accepted, and now we have a staged pull request. We can scan those and then annotate it. So you can see in the screenshot, we might say, hey, this thing's failing it. We detected credentials in it versus great, they pushed it again, and now it's passing. And then once it's in a merge state, so you might have an existing set of code, so we're not looking necessarily at pull requests, but an existing set of repositories, we can scan that as well and look for code that's already been merged in that has that. So really looking at how can we sort of prevent the secrets ending up in code at every stage of that life cycle. Next is a feature that I'm super excited about, which is how do you help make signal out of noise? I mean, it's easy to have false positives when you're looking for secrets, right? But what's a very high confidence signal that a secret is real is you have it in your vault. If it's in your vault, pretty likely that you wanted it there for a reason. And so with the vault correlation check, what we do is basically keep an index of all the secrets and credentials that you have in vault. And as Radar is scanning for secrets, it's comparing against that index. So if it finds something in GitHub or Jira and it says, hey, this is actually an exact match to something you have in your vault, very likely this is a high priority, high severity item versus one that maybe we don't know about, could be test data, could just be a fake username, password, et cetera. So it gives you a much higher signal. Additionally, if we can then correlate that into access logs, we can get a much better sense of where did that secret come from, right? If Armand was the last person to access that secret and then subsequently Armand filed a Jira ticket, you have a pretty good sense of where it came from, right? So how can we sort of use that to then give users a little bit more prescriptive feedback to say, hey, maybe don't do that, do this instead. So when we talk about giving users that prescriptive feedback, one of the other things we heard was like, well, make it easy to do that remediation. So now we introduce what we call remediation guides as well. So for different types of secrets, you can actually provide users very specific guidance on how they should remediate that. So you can do this by type of secret, for example. So you might say, OK, for an Amazon secret, we're going to do it this way. For a certificate, we'll do it for a different way. For a generic secret, maybe if there's a third answer. So now you can provide these remediation guides, which then get surfaced alongside the discovery. So here, when we actually show the secret itself and say, hey, we found this secret. It's in GitHub. By the way, here's the link directly to the remediation guide. So you can click through, and the developers can follow the steps on what they should do to actually remediate it. So from there, they would click through and it'd say, great, here's your documentation. You can either link directly to the HashiCorp sort of default documentation or change that and put custom docs that make more sense for your organization as well. Right? So let's tie all of this together. I want to kind of jump into a demo. We're going to start by having an agent pool. And in this case, we're just going to connect it up to GitHub. So the agent pool in this case was those agents that you can run on your data center. So you could be using a private GitHub enterprise as an example. And so then we're going to select either do we want to scan all of our repositories or only a select set of repositories. We're going to start by selecting a select set here. And then from there, once we configure it, we're going to do the point in time scan to go scan and find all the credentials in it. But we're also going to continuously scan for new commits, new code that's being introduced into that environment. And then right away, we can see we find a whole bunch of things, and we can come and filter it to say, I only want to see things that match a secret in Vault. So from there, we can see, great, we're seeing not only the Vault location, but we're also saying where's that secret in Git itself. And then we can see the remediation guide as well. So we can actually click through and say, great, here's how you should remediate that particular secret type. And then if we wanted, we can go and actually change those remediation guides. So in this case, you can see that it's set to the default HashiCorp documentation. But you can always change that, and maybe you have an internal wiki that says, hey, we actually do it differently within our organization. Here's a different path as to how you should manage that. Right? So you can then save and create multiple of these different types of guides. So that kind of gives you a sense of Vault Radar. So super excited, and I think the feedback we've gotten has been awesome. I love this quote from Singapore Press Holdings. For them, they really focused on the fact that, yes, they had secrets not just in Git and version control, but many different, multiple sources of leaks. And so having one tool that can scan across all of that to find their unmanaged secrets has been a huge benefit. So when we talk about finding the secrets, it's really only piece one of the problem. Great, we found all these secrets. What do we do with them now? Now they have to actually go somewhere. So when we think about secret management best practice, yes, we start at the very top, which is, OK, your highest risk are the ones you don't even know about, right? Those are your unmanaged credentials that are sort of sprawled over your estate. But then you have to think about it as it's not just in a vault or not in a vault. It's not a binary, right? There's sort of a progression of security in terms of how are we treating that key? How fresh is it, right? How shared is that key? So if I think about it, the worst case scenario is it's unmanaged, right? It's sprawled across an estate. It's unencrypted. We don't have visibility. The next best is, okay, it's at least vaulted. It's encrypted. We have access control. We have audit logging around it, all that good stuff. But for most people, they're still using long-lived static shared keys, meaning, great, I took it out of GitHub, I put it in Vault, but I haven't rotated it in 4 years, right? So you're like, it's better, but it's still not great because it's long-lived, and you have to sort of expect that that key is going to leak somehow. An app is going to log it to Splunk or whatever. So the next best thing is to say, well, how do I make sure that these keys are dynamic, right? And how do we move to a world where they're not static, but they're actually automatically being rotated? So when we talk about the bottom part of this pyramid, the next step is really moving to an auto-rotation scheme, where you say, okay, maybe based on policy, Vault's going to rotate that credential every 30 days. So it's still a shared secret. Everyone asking for the database key is getting the same one, but at least it's being changed automatically every 30 days rather than once every never, right? And then the best case scenario is you get to dynamic, where you say every single time the user requests that credential, Vault is generating a short-lived unique one per client. And that's the best case scenario, because now this key might only live for a matter of hours at a time, and it's unique to the client, so if it ever leaks, we know precisely which client had it and then precisely what time window it was valid for, right? And so there's kind of this constant progression. So for us, we're always thinking about how do we make it easier to kind of move down this pyramid and get to those sort of more idealized ways of managing secrets. So one of the things we introduced over summer was within HCP Vault Secrets, that auto-rotation capability. Right? So this allows you to specify a secret type, set a policy as to how frequently it's rotated, and then we would manage multiple versions of that secret that overlap. Right? So you can have version 1 active while version 2 gets installed, and version 3, so on and so forth. So we've added, in addition to the existing support, we've added MongoDB and Twilio, AWS and GCP, and on top of that, coming soon is going to be private database rotation as well. So using an agent, you can connect to your private network and manage that auto-rotation for things that are sitting on private networks as well. So super excited to announce that we're now taking the auto-rotation capability of HCP Vault Secrets generally available as well. So this starts to tackle that next layer of the pyramid. But that final layer of that pyramid was really the dynamic secrets that we talked about, right? And this changes the model slightly, where now the application is talking to Vault. Vault is talking to the target system to issue that dynamic credential, as we said, and it's sitting as that broker in the middle and managing the automatic rotation and revocation of those things on a very short time scale, right? So we've now brought support for those dynamic secrets as well by integrating it tightly into HCP Terraform as well. So now HCP Terraform doesn't need to use long-lived cloud credentials. Instead, it can use HCP Vault Secrets as a broker to generate a dynamic credential every time it needs for a plan and apply cycle. And that way we can move away from long-lived credentials, move to very short-lived, tightly scoped temporary credentials, and not have to worry about persistent access, right? So super excited to announce that we're taking the dynamic secrets capability public beta today as well. There have been a number of other enhancements when we think about HVS as well. One of those has been to ask to get very fine-grained in permissions. So you might want to have specific users that can read, some users that can only write, some that are read-write, some that are audit-type roles. So we've introduced much finer-grained permissions so that you can kind of slice and dice that in kind of a much more fine-grained way. And in addition, I think another ask from our enterprise customers has been to have much more real-time visibility into audit logging. So we've brought the ability to do real-time streaming of those audit logs to external systems like Splunk. So now you can ingest those audit logs in real time as users are performing activities, feed them into your SOC or other types of systems as well, right? So let's take a quick demo of what these different things look like together, right? So here we're starting with an AWS configured dynamic secret. And then from HCP Terraform, we're configuring it to read those dynamic secrets. So you can see there's no actual Amazon keys there. So we're going to just go ahead and trigger a Terraform run, just like normal here. As you can imagine, anytime a plan and apply runs, you actually need these Amazon credentials. We're talking to Amazon to do the plan, to do the apply. And we're going to trigger the apply here too. And we can see, just like normal, everything plans, everything executes, as we would expect. And now if we flip back and refresh from Vault Secrets, we can see 2 new dynamic credentials were created. One of those was created during that plan cycle. So before the plan happened, we reached out, generated the AWS key, did the planning cycle, and you see it's going to expire within 30 minutes. And then same thing again, when the apply triggered, we got a new dynamic credential, used that for that duration, and then threw it away. So this lets us get to that point where we don't have to worry about, what if that run somehow accidentally saved a key or it ended up persistent in an output or some other thing. These are very short-lived, they're tightly scoped, and they go away rapidly, right? So super excited about all these announcements. Now, as we shift gears and talk about Vault Dedicated, Vault 1.18 is available as of yesterday as well. And there's 3 big thematic areas we focused on. One is ease of use, second is reliability at scale, and third is industry-supported standards, adding more of them. So when we talk about ease of use, a number of important enhancements. One is we've been adding this notion of an event system to Vault over the last few releases. So rather than having to have clients pull Vault to detect any changes, you can actually subscribe to an event stream when a secret is created, updated, deleted, revoked, etc. And this allows you to react in real time to these things. So for example, the Vault secret operator for Kubernetes watches these event streams and can proactively trigger rolling deploys if you change a secret that an application depends on. So a bunch of enhancements to that proactive event system to add support for more different types of conditions that you can be notified from. Audit logging enhancements allows you to reduce the amount of data that Vault sends out, which can be a lot. So maybe you're optimizing your Splunk or Datadog bill, and you don't necessarily want every field that Vault can send to you, or there's certain sensitive data you want excluded. So now you can be a little bit more fine-grained in what Vault will export. And then UI support for write-only. So you might want to have situations where for whatever reason an admin has to manually configure, let's say, a COTS application, and they have access to a sensitive admin permission, and you need them to be able to manually put it in. So that's the way you can use the UI to manually input a write-only secret. Previously, the UI couldn't handle it if you only had write permission but not read permission as well. So now you can use it as sort of a Dropbox as well. Next, when we think about reliability at scale, we have customers using Vault at tremendous scale. Vault underpins stock exchanges, credit card transactions, airfare, and hotel and car ride bookings. So you can imagine that there's Vault clusters that see some very, very serious scale. So 2 very important enhancements I'm excited about. One is around Raft, which is the underlying replication leader election subsystem. And 2 is this notion of what we call adaptive overload protection. So when we talk about Raft, when we think about kind of the classic scenario, you're running a multi-node cluster, it's doing internal leader election. You have one natural leader and multiple followers that are doing data replication. And you can end up in a situation where you have some sort of a network partition caused by many different reasons. And when that would recover, the other node would try and reestablish connection to that cluster. Now, oftentimes, it's doing that by triggering a new round of leader election because that last node has lost touch with the leader. And so this would trigger a loss of leadership, right? The cluster would take a few seconds to reestablish and figure out who should be the logical leader. Oftentimes, it was the same leader because only one node was disconnected, but it would cause a blip in connectivity, right? Not an issue if you're a low-scale cluster, but it can be an issue if you're doing tens of thousands of requests a second, and all of a sudden you're offline for a few seconds, right? So one of the major enhancements was this notion of pre-voting. And this has been a specification as part of Raft that we've brought this enhancement in. So now when that partition heals, the follower, rather than first triggering a leader election, will check and say, hey, before I trigger a vote, is there an existing stable leadership? Can I just join that? It'll trigger this pre-vote sequence instead. And that allows the existing node to gracefully rejoin the existing cluster and catch up without causing leadership loss. So in our benchmarking, we found that under a bunch of different kind of torture test scenarios of this thing, you get about a 99% reduction in leadership churn because the cluster is just much, much more stable, which is great for clusters that are under load. The next one is adaptive overload protection. So if we think about an application that's multi-threaded, receiving tens of thousands of requests at a time, Vault makes its best effort to handle every incoming request, right? And that works great under normal conditions, but you can eventually end up in a condition where you have more requests coming in than is possible to handle. You completely saturate incoming resources. And so under those conditions, you can have a cluster that degrades in less than graceful ways, right? So one of the new capabilities coming in is what we call adaptive overload protection. So rather than try and handle every request, Vault instead creates a first in, first out queue of all the requests coming in, and then adaptively manages how much concurrency it's going to allow by monitoring things like latency, I/O load, CPU utilization, the number of available cores. And so it will adaptively scale and add or remove concurrency based on the real-time environment that it finds itself in. So what we find is this, it has 2 great properties. 1 is much, much better tail latency under load. 2, higher throughput. And 3, much more graceful sort of tolerance of overload conditions, right? So a very subtle enhancement that you won't notice, and ideally just prevents a cluster from ever being in an ungraceful sort of a failure mode. Next is when we talk about industry-supported standards, right? We've made a lot of focus on certificate management and PKI over the last few releases. The next sort of major protocol we've added support for is what's called CMP v2, Certificate Management Protocol. This is very commonly used in IoT settings, things like 5G networks or various radio networks, where you can easily create, distribute, rotate, and manage the lifecycle of certificates, and now you can use Vault as a broker to manage all of those life cycles. The other ones, we have customers sort of increasingly moving into pure IPv6 networks, so making sure that we are certifying Vault for all of the different kind of use cases, different kind of capabilities and secret engines to make sure it's ready for an IPv6 only network. So now we've kind of covered two large aspects when we think about the security lifecycle management. One is obviously the inspection with things like Radar, the protection with things like Vault. The third piece of this is really the connection, right? What about the human users who often need access, right? And oftentimes the human users are, the weakest link in the chain. So how do we think about them getting access to these environments? Well, when we think about traditional privilege access management, we see a number of problems, right? Oftentimes you have a user who's VPNing into a production network, and so they have sensitive network access. Oftentimes they need access to one system, but they're sitting on a VPN with access to thousands or tens of thousands of networks, of endpoints and systems that they don't necessarily need access to. This is obviously bad, so then organizations try and fix it by putting firewalls in place, which introduces another problem, which is now you have a bunch of brittle IP rules, right? You have a highly dynamic infrastructure, things are coming and going, and now you're trying to keep these IP rules up to date. And so what do you end up seeing in practice? Allow all to allow all, right? So you have these brittle IP rules that become difficult. And then the last one is sort of the sin we've probably all seen, is the dreaded shared SSH key that accesses thousands of machines and has never been rotated, right? And so you kind of see this problem over and over again in different organizations, and this is what drove us to ultimately create Boundary. And with Boundary, we said, okay, we want to move away and solve all three of those problems. One is users shouldn't have access to a long-lived shared SSH key. Instead, you're just going to do a single sign-on against your identity provider. Two is we're not going to give you network access. Boundary will act as a direct reverse proxy to whatever you need access to, so you don't have access to tens of thousands of hosts that you don't need to be on network with. And lastly, you should really never see the SSH key. We should transparently broker that from a system like Vault. It should maybe be a dynamic, short-lived SSH key that's only valid for 30 seconds on that one machine, rather than a long-lived shared key across a wide fleet. Now, I think the challenge, or maybe friction point, had been, what you lose, or what you gain, I should say, with a VPN is that it's easy. It's transparent. You connect once, you're on network, you never think about it again, you can access to whatever you want. With Boundary, you had to think about it. You had to say, okay, I want to establish a connection to this particular host, or this particular system, and then Boundary was going to establish that connection for you, but you had to be somewhat explicit about what you were connecting to. So this added some amount of user friction as you had to think about these systems and establish that connection. So we sort of thought about, is there a way to get that ease of use, the sort of benefit and transparency of a VPN without the sort of loss of fidelity or loss of zero trust that you get with Boundary? And super excited today to announce what we call Boundary Transparent Sessions. So I think this feature is best explained by just seeing it work. So I want to just jump right into a demo, and this is available today as part of Boundary 018. So just like our standard Boundary flow, we're going to log into Boundary. So we're going to do a sign-in on our desktop client. In this case, we're just doing a single sign-on. And right away, we'll see the list of things we have access to. So as a developer now, we might open up our terminal, and we're going to SSH into a target host and connect to it. And we can see that we were connected. And that's it. We didn't have to do anything. And so I think the magic of this here is, unlike having to come into the UI, manually click what we want, establish the session, think about, okay, what's the IP and port that I needed to now use to connect through with Boundary, we didn't have any of that. Because the way Transparent Sessions works is it's sort of hijacking the DNS subsystem. So the moment the user typed SSH with their host name, we hijacked that host resolution, Boundary intercepted that, figured out that you actually have access to that host, created a session, and steered you to a private IP and port transparently behind the scene. And so the user didn't have to think about the session management at all. Right? You just type in the host. As long as you have access, boom, you're in. If you didn't have access, you're going to get an error message back. Right? And so it gives you that ease of use, the transparency of sitting on network without the downside of actually being on the network. Right? So super excited about this capability. I think it's made a huge stride in just the user experience of Boundary, and excited to get the community feedback on it. So when we think about the different forms of access, obviously we've talked about machine-to-machine secret brokering with Vault. There's sort of human-to-machine with Boundary. And then the third is kind of machine-to-machine networking that we often think about the role of Consul. So Consul's role is typically used as sort of a service discovery engine and broker between many different platforms, many different environments. So you might have VMs and containers, you might be on-prem and in cloud, you might be all of the above. And so oftentimes Consul acts as sort of a universal registry of all those things. It knows where everything is running, it allows apps to navigate and communicate across different platform and cloud boundaries. Now the challenge though is you don't necessarily want everybody to be able to talk to everything, right? Much like we don't want our human users to have access to all of these different systems, we don't want our applications to have access to all of these different services as well. And so Consul's always supported an ACL system. You can segment access. You can run a full-blown service mesh and do mutual TLS. But some of that stuff has a lot of operational overhead. Maybe I just want something simpler, which is you shouldn't be able to discover a set of services. So one of the new capabilities I'm super excited about is what we call Consul DNS views. So much in the same way we hijack DNS with Boundary, we can hijack DNS with Consul to do this from a service-to-service perspective. So particularly within a Kubernetes environment, we can hijack the DNS system and basically know who the originator of a DNS request is. We know it's service foo. And then based on the fact that it's service foo, we know, well, what set of services should you actually have access to? So you can almost end up with a sort of virtual private view of DNS unique to who the requester is. And that DNS view then lets you restrict what you have visibility to only the subset of services you should be able to discover. So this gives you sort of a transparent way to bring in some of those security controls, minimizing the surface area of what you can access without necessarily having to operationalize a full-blown service mesh. So this is a new capability that's available as part of Consul 1.20, which is available today as well. So thank you, one excited person. So taking a quick step back, I think we've covered sort of the security lifecycle here when we think about that whole journey from inspecting, detecting the secrets, protecting them, and then brokering the connection between both our human users and systems. And so now I'm excited to welcome Dale from SAP to talk through their journey about how they've thought about implementing and scaling up some of their secret lifecycle management. So join me in welcoming Dale.
Everybody.
Hey Dale, good morning. Thanks so much for joining us here. So maybe just to kick us off, I think probably most of us have heard of SAP, but obviously SAP has many different moving pieces and many different sub-corporations. So maybe share a little bit about SAP, SAP Concur, which is the org you're sort of a part of, and your role.
Yeah, so SAP, everybody knows them from enterprise resource planning software. That's probably the biggest use case. They have other verticals like expense management, and that's where Concur comes in. Companies use Concur to automate their travel and expense reimbursement. And yeah, so that's the company.
And what's your role there?
My role is as a principal engineer. I lead our Vault effort within our multiple environments across multiple regions.
Awesome, thank you. I think most of us here probably had to interact with your software to book our flight and then certainly to expense it on our way back. So I think all familiar, and thank you for keeping us secure.
All right, thank you.
So maybe before we sort of jump into it, give us a sense of, rewind the clock a little bit. Before you guys were using Vault, what was sort of the state like? What was the problem? What were you guys hoping to solve? And what was the sort of trigger to sort of start using Vault in the environment?
The trigger really is just remove friction from adding security to an environment, right? So to do that, we wanted to make our audits easier. Your largest customer today and what they want is what your customers will want tomorrow as well. So we want to basically remove the friction of the audits and just make it easier for our engineers to sign PKI. We'll use PKI to sign certificates.
And I think what I love about that is it sort of ties into what I started the keynote about, that sort of transition, what we saw in security from almost that reactive approach to the gatekeeping approach to really, I think what you're talking about here is sort of security integrated into the platform experience.
Right, because one of our use cases within the environment is we needed to enable a web of trust, and that meant PKI, and we wanted to remove the friction of signing those certificates and getting that web of trust, right? So
exactly. So then tell me, so then you guys started using Vault open source. Maybe walk us through a little bit of what was that adoption journey like as you brought in the open source, and how do you start to integrate that into the sort of platform experience?
Well, first, we wanted to run Vault in a multi-tenant fashion. So the first thing we wanted to do is obviously enable namespaces to give that role-based access control for our teams. And the initial Vault that we had in place, of course, it was kind of like the Wild West. I mean, we had it there, but it wasn't very prescriptive. Our teams could use it if they wanted to use it, and et cetera.
And so it sounds like the first use case very much started with the PKI, and I think that was in service of Service Mesh for you guys. Mm-hmm. And then along the way, was there other engines and use cases that you started enabling as well?
Yeah, we enabled, of course, key value and database credentials as well.
Awesome. And so then I think as you started sort of thinking about those different use cases that you rolled out, what was that experience from a developer perspective? Meaning, did they have to interface and rewrite their applications? Did you guys use sort of a platform-based integration? Or how transparent was it for them to sort of get their database credentials, get the certificates? Like, walk us through how much the developers sort of had to experience the plumbing versus the porcelain.
Well, that's what we wanted to hide, was that plumbing. I mean, you had a perfect slide yesterday where you were showing underneath the kitchen sink. We wanted to remove that. So as we were rolling this out, we took that mindset. We wanted to enable our engineers for that self-service model and remove all the underneath stuff that they don't care about. They just want to be able to take a certificate, call their dependency, and get a response, right?
Yeah. So within sort of your Kubernetes environment, how did you guys go about integrating Vault?
From there, we just used the K8's auth method. So when your pod comes up, you just automatically have a token within your pod. And of course, in the service mesh, it's already rotating your certificates and making it easier and transparent for them, for the service user. And if they need to make other calls for other use cases, they already have the token to make those calls. They don't have to do the login themselves. So that's, again, removing the friction.
So sort of, to me, I think a perfect example of that kind of platform integrated security. Developer kind of doesn't see Vault, think about it. Certs are installed for them automatically and rotated. Database credentials are presented and rotated, kind of fully invisible to them.
Yep, exactly.
So then maybe walk us through a little bit. You mentioned already a little bit about things like namespaces. As you move from the open source version of Vault, sounds like it was a little bit Wild West. I know you guys had how many clusters initially when you started with the open source Vault?
Well, when we first started rolling out Enterprise, we had probably a total of 27 environments across our whole org within Concur. So when we started rolling out Enterprise, we really wanted to consolidate that. Just go Enterprise full force, add parity, because again, friction for the end users. They don't want to have to think about, okay, what's that FQDN for Vault in this environment? We wanted to remove those branches from their thinking.
And then you guys managed to get that down from 27 distinct environments into how many, using then things like namespace as well to make it a bit more multi-tenant?
As of right now, we're at 8 environments.
Got it. Okay, so just sort of a massive reduction in sort of the total surface area that you had to kind of manage, move to a bit more of a multi-tenanted model. Makes sense. And so then, along the way, I'm curious, were there some lessons learned in terms of the maturity of that deployment? Things you had to sort of harden from sort of going from the maybe chaos mode into the bit more centrally managed, delivered as a service, sort of a shared application?
Yeah, the lessons learned are, start with your use cases. So what's the first use case you want to remove friction around? For us, it was PKI. So we enabled just that secret engine within the environments. It's not carte blanche, you call Vault and use it however you want. We enable specific use cases within our environment for teams to use. So from there, the other is just find the lowest common denominator for your security. It's all about parity. Don't make them have to think about it. Key links, all this type of stuff. Just put it there in front of them that meets the policy for the environment.
Makes a ton of sense. So then as you sort of think about these different efforts, obviously there's a lot of work that goes into sort of rolling this out, implementing it, doing all the platform integration. When you take a step back, how do you think about what success looked like, right? Like, how did you measure that? How did you think about, hey, this is the goal, here's the outcome we're shooting for?
Yeah, the success is all about removing that friction. That was the first thing. And just listening to our engineers who are using the service and making sure that we're removing that friction. So when we take a sample of just an hour in one of our environments, we signed over 2,100 certificates, 8,000 secrets retrieved, and around 12 to 14 database credentials rotated.
So for me, as I just sort of do that back of the napkin, I'm thinking, okay, you're talking tens of thousands of certificates a day, thousands of database credential rotations, on a monthly basis. And for a lot of organizations, what we see is that those are manual activities, right? I see most organizations, I file a ticket, I get a cert, I manually redeploy, I talk to the DBA, I rotate a service account. And so for me, I'm doing that math and I'm thinking, how much developer toil effectively did you manage to sort of offload from them?
Yeah, it's countless hours. I mean, you can even make a number up.
Which I'm sure the developers miss, though.
Oh, yeah.
I'm sure that was quality time. So there's clearly, I think, a side of this equation, the sort of the developer efficiency and sort of the toil aspect. To me, I think there's the other side of it, too, which is sort of the risk posture, right? Like, if you're rotating thousands of certificates a day, or an hour, really, what that's telling me is these are short-lived certs. You're moving away from long-lived database passwords. You're moving away from long-lived certificates. Curious if you have sort of a notion of, like, what was the before and after? Like, how long is the average life cycle of a cert now versus what it was, 3-4 years ago?
Before, we had longer TTLs, about a year. But now we're moving our advice to our teams are 90 days, and then start trying to renew that certificate if you're doing it yourself in an automated fashion at the half-life. Otherwise, it's just being taken care of for you at a different layer.
So then in practice, really, it's almost every 40 days, really, these certs are being rotated, right?
Yeah,
so,
40, 45 days.
Versus sort of probably a year.
Yep.
So almost 10x reduction, right? So to me, I think that's a huge side of not just developer toil, but there's also a massive risk reduction and sort of the posture of the firm as well.
Yeah, and I mean, even going all the way down to the trunk, the root of our chain, we rotate that every year.
Right, which is huge. I don't think most people could say that every decade. So then as you sort of cast out ahead, I know you started with SAP Concur. You guys are now at a relatively high maturity within the Concur organization. How do you think about the role now of Vault within sort of broader SAP and sort of the roadmap of where you're going?
Yeah, right now we're still on that roadmap for maturity even within Concur. We put a lot of upfront investment in just making it easier for our engineers and removing that friction of security. So now we're trying to take a step back. How do we make our lives easier as a team in our operations of the environments and just make it easier there? So.
Got it. So enable new use cases, make it easier, and then continue to onboard new applications across broad enterprise.
Yeah, for instance, like we're using namespaces, but say a team just wants their own Vault cluster and just run one namespace. We want to be able to offer that.
Got it. So make it more self-service, drive more sort of automation around sort of the provisioning and delivery of that to app teams.
Yep, exactly.
Awesome. Well, Dale, thank you so much for joining us and sharing your journey. Hopefully, I think enlightening for other folks as well to kind of learn from you guys.
Yeah, I hope so. Thanks for having me.
Please join me in thanking Dale. Thanks so much, buddy. Awesome. Thank you again, Dale. I think it's always awesome to hear from customers on their journey. I think what to me is interesting is like we sort of often think about that we are special as snowflakes in our journey on security. And I think it's helpful when you come to an event like this and you realize we're kind of all going through that same maturity curve. We're all facing the same sort of challenges. And I think in particular for security, oftentimes it's something we don't want to talk about, but I think it's helpful to share and learn from one another. So again, I think it takes a lot of nerve for someone to come and share it in front of thousands of people. So another quick round of thank you and applause for Dale. Awesome. So lots and lots of different announcements that we covered today. Again, I think covering the entire spectrum really from inspect with the availability of Vault Radar. Go use that today. A lot of enhancements to HCP Vault Secrets and the introduction of auto rotation, dynamic secrets, and integration with HCP Terraform. Lots of improvements to Vault 118 also available today, making it a lot easier and hardened at scale. Boundary with transparent sessions, as well as Console 1.20 with lots of improvements and DNS views. So lots and lots of great announcements. But we have one more final special announcement, which is that we'll be going back to our hometown next year to San Francisco for HashiCorp 2025. So early bird tickets are now available today, and I just was told by our events team that one of the first 50 registrants will actually get all of their hotels covered as well. So good luck. Thank you all so much for coming and joining for HashiConf. We have a great set of content for the rest of today. I hope you enjoy all the other sessions and hope to see all of you again next year. Thank you so much.